Hello, dear students. In the ninth standard and in the 11th standard, while studying the structure of atom, we have seen that J.J. Thomson and other scientists have passed the electricity through the vapor of gases. Same way, after this scientist, one more scientist named Faraday, he has also passed electricity through the various solutions and he has studied them. So, Michael Faraday, a contemporary after this scientist J.J. Thomson and Chadwick, passed DC current through the electrolytic solution of various electrolytes and melts of the electrolytes. Melts means molten liquids of the various electrolytes and published his results. The results were known as the Faraday's two laws of electrolysis. Faraday observed that if active electrode is used, it is the refining of that metal or that element, and if inert electrode is used, we shall find metal deposited or gas liberated or produced at anode or cathode. So, this is what it was the observation of Michael Faraday. Michael Faraday laws are actually the quantitative aspect of electrolysis. Michael Faraday was giving us the quantitative idea that what quantity of metal can be deposited and what electricity should be passed. So that is how we can say that these laws are the quantitative aspects of the electrolysis. So these laws tells us about amount of element produced at anode and cathode and its relation with the amount of electricity passed through it. The first law, if we look at the amount of chemical reaction which occurs at any electrode during the electrolysis by a current is proportional to the quantity of electricity passed through the electrolytic solution or melt. See, when we look at the first law, it says that the more electricity you pass, the more metal is deposited. The less electricity you pass, the less metal is deposited. What does the second law tells us? The amount of different substances liberated by the same quantity of electricity passing through the electrolyte or electrolytic solution are proportional to their chemical equivalent weights. That means that if we pass the same amount of electricity through various electrolytic solution or various melts, then we will find that the metal deposited or the gas liberated is according to their chemical equivalent mass. So if someone has got more chemical equivalent mass, then more metal or more gas is liberated. If some element has got less chemical equivalent mass, then less gas is depleted or less metal is deposited. Now the question arises, what is this chemical equivalent weight or chemical equivalent mass? So chemical equivalent weight or chemical equivalent mass is equal to atomic mass of the metal or atomic mass of that particular element divided by number of electron required to reduce the metal atom. So if the metal atom has got plus 1 charge, this number is 1. If metal has got 2 plus 2 charge, this number of electron required to reduce the metal ion is 2. If the metal has got plus 3 charge, then 3 electrons are required. This is how we can understand it simply, and we can understand the chemical equivalent or its definition or how to calculate it. The quantity of electricity passed through is Q, which is measured in Coulomb. We know that Q is equal to IT, where I is the electric current and T is the time for what the electric current is passed through. Current is passed through the electrolyte or electrolytic solution. The amount of electricity or charge required for oxidation or reduction depends on the stoichiometry of electrode reaction. So to understand or to solve such problems, we will have to look at the electrode reaction. Suppose at one electrode Ag plus one aqueous gives takes one electron and it turns into Ag solid. So if there is only one Ag plus ion, then you need only one electron and 108 unified mass of Ag can be deposited. Now if we take 1 mole of Ag plus ions, that means we will take 6.022 into 10 to the power 23 electrons. That means we will get 108 gram of silver deposited. Same way, if we really calculate the electron or the charge on the electron, it is equal to 1.6 into 10 to the power minus 19 coulomb, which is the charge of one electron. And now we have 1 mole electron, that is 6.022 into 10 to the power 23, so that needs to be multiplied, and by calculating this we get this answer 96487 coulomb. So this 96487 coulomb is the charge of the 1 mole of electron. That is what we understand. This charge present on the 1 mole of electron, which is known as the 96487 charges, coulomb charges, is also known as 1 Faraday charges. So my dear students, we need to know that this charge is simply known as the 1 Faraday charge. And on passing 1 Faraday charge from Ag plus ion, we get 108 gram, which is the molecular mass of the silver, or it is also the chemical equivalent mass, because here we need only one electron. So this molar mass divided by 1, and that is why we get the chemical equivalent mass. So now we understand, if 96487 coulomb charges are passed through the electrolyte with Ag plus ions for 1 second. Now remember, it is also important that we pass the charges for 1 second. 108 gram of silver will be deposited on the cathode, because cathodic reduction takes place. Remember, my dear student, that 96487 coulomb 96487 coulomb, that is Q is equal to IT, therefore T is equal to 1, and we just pass this for 1 second, and that is why we write I into 1 is equal to 96487 coulomb, that is I is equal to 96487 ampere. So even using this equation, we can realize that we would have passed 96487 ampere current for 1 second through this solution to get 108 gram of silver produced on the cathode. Now we'll go and understand the second example. Second example is for copper. So at cathode, suppose we have copper deposited, then Cu plus 2 gives, that has 2 electron, and it turns into Cu solid. Now if you take one ion of Cu, you will get 2 electrons, and then 63.5 unified mass of copper will be deposited. But suppose if you take 1 mole of Cu plus 2 ion, then you will be in need of 2 moles of electron. 1 mole of electron, that means 1 Faraday. 2 moles of electron, that means 2 Faraday, and you will get 63.5 gram of copper deposited on it. Now look at this calculation. 2 moles of electron means 2 into the number which is known as the 6.022 into 10 to the power 23, that is multiplied by the charge present on each electron, and finally we get a 2 into 96487 coulomb charge, which is known as 2 Faraday charge. So when you have 2 Faraday charges, you get 63.5 gram of copper, but when you pass 1 Faraday charge, you get 63.5 divided by 2, that is 31.75 gram. This 63.5 gram is the molar mass of copper, whereas 31.75 gram is the chemical equivalent mass of copper. So by passing 1 Faraday charges, we get the 1 gram equivalent mass of any element that is produced. Remember, this is what it is known as the gram equivalent mass for copper, and by using this formula, equivalent mass is equal to atomic mass divided by the number of electron required to reduce the metal ion, that is 63.5 divided by 2, and finally we get 31.75 gram per mole. Here we understand it very easily. Thank you, my dear students.